Hello everyone and welcome to the second part of our matrix operations in C++. As you remember from the first tutorial, we created two methods of declaring and using matrices. The first one was quite stupid because for having just one matrix you had to write like 10 lines of code, and it was not really manageable because you couldn't do much with those. You couldn't pass it to other classes or other functions that easy. You had to make functions with like 10 arguments. And then we tried a better method and we introduced some functions that could, for example, generate a matrix on the heap for us, print a matrix, populate the matrix from a source. For example, we used just a one-dimensional array as a source. Then we had these simple add matrices that could add two matrices together. But the better solution would be encapsulating the matrix all together inside the class. And initially I wanted to make a template class that could cover all kind of data types like double, integer, float, unsigned int, and all those kind of stuff. But then I said maybe some of you are not really familiar with the concept of template classes. So for this tutorial we're just going to make a normal class, and possibly in the next or the next after that we cover all the matrices inside the template class, so we could reduce our code size even more. So let's go ahead and make a class that gives all the functionalities necessary to have a matrix. So for that I am going to make a new C++ class, and I will just name it matint, and it stands for matrix of type integer. And I would like to wrap it in a namespace so it doesn't get confused with other classes. Maybe there are some other classes in the standard library, I don't know, could have same names, but it's safer to have our own namespace. And I'm going to call this namespace matops for matrix operations. Okay. Now we can start coding our class. So first of all we need some private members. We need the rows. And always it's a good practice to initialize your variables in C++, because if you don't and you forget to do them, you will get undefined behavior. So that's out of the way. Let's continue the columns. And we need a field for the matrix that we're going to generate inside this class, because each class will have only one matrix inside it. Okay, so we just call this simply mat. Okay. And now let's make some functions. And first of all, the constructor. For the constructor we just need to know the number of rows and columns that the user wants to have. Then let's not forget to make a destructor, because as you know you have to manually delete anything that you have created on the heap. Otherwise your application will have memory leakage. So that's the constructor and this destructor. And let's add some other functionalities. For example, we could bring in the generate matrix just directly from here. But let's first write its declaration. So I'm just going to say int of type double pointer generate matrix. And because we might need to resize the matrix internally in the class, we also need to have two arguments of type integer for rows and columns. And this is useful for example, if you want to multiply two matrices together, then the resulting matrix will be of a different size. So that's one for generating the matrix. And let's make a void function to print the matrix. Void print. and just some other functions. For example, void transpose. I will just name it trap, and let's add one function for example, adding with another matrix, add, and this one is going to be of type matrix itself, matint, and it's going to be a reference type, m, and we can do this for addition, subtraction, multiplication, and division. Okay, and there's a high chance that we need to have this function int get value at row I and column j, and you will see why very short. So now I think we have enough functions, but in any later time we missed anything, we can just come back and add it to the class. So let's start implementing these functions. Let's give them the definition, and for the generate matrix I'm just going to simply copy paste what we had from the first tutorial, and let's first of all generate a destructor. And the destructor, what it does when the operating system knows that this matrix is not needed anymore, it will just delete it for us by calling the destructor of the class. So to delete this matrix from memory, we just simply say make a for loop. We will go over the number of rows that we have. Rows. Then we delete the matrix that we have inside the class mat at row I, and when all the rows are deleted, then we finally delete the main pointer. Delete this dot mat. So with this we can be sure that our program is not going to cause memory leakage or all those kind of nasty stuff. Now let's go back and let's this time implement the print function. And for the print we need to include IO stream to have access to console output. And for the simplicity we're just going to use the standard standard library namespace. So using namespace std, then we don't need to write down std for every cout or end line. Okay, so let's copy paste this from here, and we have to make some changes because now we don't have the matrix here anymore. We have to call the matrix within this class. Okay, then let's go and from here then we have to do some mathematics. So let's implement the transpose. So as you may know, the transpose of a matrix is just a new matrix that has the rows and columns of the of itself replaced. For example, if I go to Excel, I can make a quick demonstration for you here. For example, if you consider this matrix 1, 2, 3, 4, 5, 6, then let me give it some border. Then the transpose of this matrix will be 1, 2, 3, 4, 5, 6. Okay, so the transpose operation will be this. So let's go back to our code, and because this function just operates on the class itself, then we need to internally perform this operation. and update the pointer to the new resulted matrix. So let's generate, let's say int temp equals generate matrix, and we know the result will be the same matrix but with columns and rows swapped out. So for the result we need to pass the columns as rows and rows as the columns. Okay, now we simply go our all the elements in our original matrix, and we simply say excuse me, because we have to change the way we do this thing. We have to go over the columns and go to the over of the rows, and then we say temp at row I and the column j equals this that mat at I and j. Okay, then we just simply first of all we need to delete the old matrix. So to delete the matrix we just simply need to delete all the lows, and at the end delete the matrix itself, the pointer. But we can now say this dot mat equals, because at this point the memory that was occupied by the mat object, mat matrix is now free, so we just assign it to the temp. And what we need also, we need to swap the rows and columns that we have. So for example, I would say int temp equals this dot columns. What's the problem with that? Oh, it's already we have defined temp. So, and we say this dot rows equals this dot calls, and this dot calls equals temp. Okay, I think it should work, but if we face any problem we just come back and we see what we can improve. So let's go back to our header file, and we forgot to put the populate method. So I'm going to say void populate matrix, and this time we just need to know the pointer to the source array that we have and the size of the source. Okay, now let's add the definition, and again I'm just going to simply bring it from our old code, populate matrix, and let's paste it in. Let's replace the arguments that we have changed their name, and here we should say this mat, the mat in this class at row I at column j equals the item at source at the given position. And this is not a very elegant way of error handling, but later we can come and introduce exceptions, but it should work for now. So I think we have enough functions defined that we can go and test what we have done so far. So let's go to the main, and I will delete all these three functions that we already had, and I'm going to include the mat int header, and let's try a new matrix. Now this time we can say mat int mat, and let's make it something like 3 by 2 by 3, and let's create a source matrix, a source array, so we can fill it with this source. So 2 by 3 will at least requires, I mean exactly requires 6 integers. So I'm going to say source A, and let's rename this one to mat A. Source A equals I don't know, 1, 2, 3, 4, 5, 6, and it should be an array. Okay. Then we can call mat A dot populate matrix, and we give the source, and we just hard code 6 here for now. Then we can come back and make it dynamic. But I think I have forgot something inside the constructor. What we need to do is generate a matrix. So we would say this.mat equals generate matrix of this.rows and this.columns. Okay, so it's the constructor. It's not really necessary to bring it to the source file, but it should work. Now we just print the matrix, and we print a new line, and we do a transpose on the matrix, mat_a.trap, and we print it again. So let's see what we have done so far. So let's run the program. Okay, seems that we have some problem. Initial matrix was okay, 1, 2, 3, 4, 5, 6, but when we wanted to print the transpose matrix, we faced this problem. So let's check what can be wrong. What I'm thinking is that we shouldn't have this delete here, because it will delete the entire variable. So let's try it again. And still it's causing the problem. So let's put a debug point here, and let's try to debug it. So we are coming here, and I and j are 0. So the temp is a matrix of this type. Okay, let's go ahead. J equals 1, j equals 0, j equals 1, 0, and we get the segmentation fault here. So I think the problem boils down to here that we had to read the other way around. So we had to read from the column and the row in the reverse order, and this will fix the problem. And I noticed another problem here, because we want to swap rows and columns of original matrix. So the temp variable should be the rows, because then we assign rows to columns, then we assign columns to temp, which will be an old copy of the rows. So I think this should work now. So let's try it. Okay, so we have 1, 2, 3, 4, 5, 6, and we see that it has been successfully transposed. So let's move on and go back to the header file. So let's add the add functionality, and the addition is quite easy, but we're going to go back to the main, and I think I have deleted it, but anyway, we say for all the rows that we have, and again for all the columns that we have. Then we just simply say this.mat at row I and the column j will be added by the passed argument m.getValue at I and j. And for that we need to go back to our header file and we need to implement this function first. So we just simply say return this mat at I and at j. Okay. Now let's go back to the main function and let's create another matrix. So I'm just going to copy paste this again, our second matrix, source B, and this one is name B, source B. And if you remember, if you give the reverse of the matrix, add it by itself, it will be all the elements will be the same number. So let's say 6, 5, 4, 3, 2, and finally 1. And mat B populate matrix B. So let's print matrix A. Let's print matrix B. And let's add to matrix A matrix B. Okay. Then we need some new lines so we can see them more clearly. Okay, and here. So let's see what happens. Okay, we have a problem here at which line? At line 2, 3. Okay, I forgot to call the function. Okay. So let's see. Okay, and the addition also works, but I would be careful and add a check here. So we'll see if this dot rows does not equal the other matrix's rows. So we have to go back to the header file and introduce another function. Int get rows, get num rows, and int get num cols. So we can see what are the number of rows and columns inside this matrix. So we just simply here return the rows, and for this one we just simply say return these columns. Okay, when we say here if this rows does not equal m.get rows, or this dot columns does not equal m.get columns. Okay, then we simply say cout matrices should be of same size, rows and columns. And I know that this is not a good way of error handling, but we just keep things simple. We just, in case of any error, we just exit the program. If you want something more robust, you can replace this with kind of exception handler. Maybe we do that later. So let's see if this error checking works fine or not. Okay, so I'm just going to add like 2 more numbers to here, 2 and 3, and let's increase this by let's make this one 3 by 3, so we need 9 elements, 3, 6, 8, and one more. And let's try the code. So we have to jump out of the code. Okay, size of the matrix is not equal to size of a source array. Okay, so our program successfully terminated. And what remains here is just this subtraction, multiplication, and division. But I think because this video is going to already be around 30 minutes, we will leave them to the next tutorial. So I hope you learned something. We faced some problems here, and we tried to debug the problem. So I didn't want to just stop the video and fix the problem and come back again. So I thought if we fix the problems together, maybe we can learn something more. Okay, and see you in the next tutorial.